Hey everybody, Bryce here from codelife.io, and today we're talking top 3 hardest computer science classes. So for myself, I went to a college called the Citadel. It's a military college in South Carolina, and while studying computer science there, came across a couple of difficult classes. So let's go through what some of those difficult ones would be. So probably the third hardest one probably take is a computer science course called operating systems. So in operating systems, you're going to talk about basically how the foundational principles that are, controlling and operating your, Windows or Linux operating systems. So you get into stuff like memory management, thread management, processes, how do you schedule tasks on the CPU, input output, dealing with interrupts, how do you handle certain situations, like there's deadlock situations where two items are trying to grab resources, but one's holding it, one won't give it up, etc. But very challenging class, partly because a lot of stuff in operating systems is pretty low level. And so some of the programming you might have to do for the course is going to be in C, which I'm not sure if you can see this, but this is kind of the de facto book on the C programming language by Brian W. Kernighan and Dennis M. Ritchie. So if you're interested in getting into C programming, this is the book you'll want. But you do a lot of low-level stuff, and you do a lot of stuff in C, trying to get close as you can to the hardware for a lot of the stuff. But really, really fascinating class, but definitely pretty difficult. Trying to understand some of the problems with operating systems and how you solve them. So the next toughest, I would say, the second hardest, is probably discrete mathematics. So I just pulled up a page here on Wikipedia about discrete mathematics. And discrete mathematics is a math class, probably unlike any other math class I took. I took, calculus 1 and 2. Well, I guess pre-calc, if you count that, pre-calculus, calculus 1, calculus 2, linear algebra, and this one, probability and statistics, that was another one. And this one is probably one of the most challenging ones, because it's so different and abstract kind of from what you've done before in a math class. So you can see here we have a graph. So you do a lot of stuff with graphs, like how do you traverse this graph? We only touch each point one time, and then, sometimes there's weights assigned to each one of these edges. So as you traverse, what's the least amount of, points or whatever you accumulate along the way. So like stuff like that's very fascinating if you're doing graph or like trying to do driving directions, for example. So if this distance between 6 to 4 is, 3, and then 4 to 3 is 2, and from 4 to 5 is only 1, then you got to say, I'm going to take this path and this path and this path based on shortest route. But it's super fascinating with a lot of the graphs. Here's some other stuff like you talk about, like how do you divide this up where colors don't touch one another using only 4 colors. So a lot of stuff in graph theory. Another big part we talk about is what's the runtime and complexity of like these algorithms. So this particular sorting algorithm and the way it sorts, how does that, how long does that take? So you learn about big O notation. So you probably hear that, and a lot of like probably programming, well, not all of them, but I'd say a lot of programming interviews, you get asked big O notation, which is essentially what's the, best case runtime, worst case, and average runtime probably of, various different algorithms. You get into some stuff about bases and numbers and, what is this number in binary versus base 16. And you realize they're just, representations essentially. Set theory. So it's another interesting part. You have different numbers in a set and doing different things with those sets, showing that certain items are included. Super fascinating. What's some of the other interesting stuff in here? This is what I was going to show. So one of the most challenging things about that discrete mathematics course was, to me, the mathematical proofs. So let's see. So you can see in here, so here's a bunch of different ways you can prove things. And so like one of the first days of class, you're asked to write a mathematical proof, proving that, 3 is a odd number. You're like, how do you prove that? It just is by the way that it is, right? And so you have to use one of these proofs, essentially, these different techniques, and you can show, based on, here's a proof showing that all even numbers are, n times 2, can be defined by that. Whereas, if it's not that, then it is odd, because based on some other proof that somebody else has come up with, you can use that to prove your stuff. So that part was really challenging, trying to figure out how to write those proofs in a way that made sense. And you can kind of see some of the math down here, and you write it out. Because sometimes you actually write out the math, and it doesn't look like hard math, just 2n minus 1 plus 2 equals 2n plus 1 equals... So you're kind of breaking them down to eventually get to where like 1 equals 1 or whatever it may be. So super fascinating stuff. I enjoyed the class, but definitely very different from the other math classes I've taken. And so finally, here again at the Citadel website, great school, by the way. You should definitely go there for computer science if you're interested. So here's another course I took, data structures and algorithms. So in some colleges, these data structures and algorithms is combined as one course. Some colleges do them as 2 different courses. Just depends on the school. So this for me is the #1 hardest class. And it's pretty early on. You see this is a 223 class, whereas like the operating systems one is a 405. So you're typically not doing this one to your junior or senior year. Was this one, I think it's like sophomore year, you typically cover this. And when you do an undergrad computer science degree. And so for this one, it's very interesting. You learn about lists, stacks, queues, hashing, so all these different data structures. And then at the same time, you're learning about how you use data structures and various algorithms. So it kind of goes great, like hand in hand, those two things. And that discrete mathematics course kind of plays into this, where you're talking about sets, and it's like, okay, if you use a set, which is a particular data structure, then what kind of things can you do to manipulate data? So let me show you. So I got this other book, Algorithms 4th edition. I'm not sure, hopefully you guys can see that, by Robert Sedgwick and Kevin Wayne. So this is a pretty decent book. You can see, hopefully you can see that, but it gets into some various algorithms, how you use binary trees for searching, for sorting, balanced trees, red, black trees, all kinds of stuff, graphs. So you talk about a little bit like some of the stuff from the discrete mathematics course. How do you, if you were to build like Google's maps, driving directions, like how would you do that? How would you figure out how to traverse all those different things? How do you traverse mazes? All kinds of very, very interesting problems. And so this is a very foundational course if you're going to study computer science. I've used this time and time again in my career. Hashing, super important. A lot of stuff, a lot of these are using databases and lookups, and how do you look up data faster? So very, very fascinating stuff. So great, guys. Thanks for watching. So those are my top 3 most difficult computer science courses: operating systems, discrete mathematics, and then data structures and algorithms. So if you're going to study computer science, watch out for those ones, but they're not bad. If you're really into the stuff and you're very interested in learning, it's not too bad. So thanks for watching, guys. Make sure you like and subscribe. It helps others find the videos. So if you appreciate and really enjoy the video, please like and subscribe and share with others on social media. Thanks, guys. Take care.